Let's move on to another question. Here it says to find the tangent to the curve given by this. Now here you can see there are two variables used here, r and theta. But the thing is, now r is not a variable actually, okay? R is considered to be a constant in this case. So this fact should be given. Actually now this parametric representation is called the cycloid, right? Cycloid. And it's like you don't have to memorize all these things, but it's some sort of a special curve that they have in these parametric representations. Anyway, now what you should keep in mind that is that when you are dealing with the computations, this r is just a constant, so the parameter runs through the variable theta. In fact, this x is a function of theta, and it is not like this r number is not changing step by step, right? So now remember, in the previous representations you had t as the parametric variable, and we can even multiply the t by a certain number, right? So like putting all these things together, we can direct at once say that the given variable depends on this parametric variable, right? So a similar thing happens in here. R is just a number and x and y will depend on theta. So theta is the third variable that we have, right? So here we need to find the tangent. So finding the tangent means finding that equation of that straight line. So to find the equation of a straight line, we need the slope, and that is represented by dy by dx, and the point that this line passes through, right? So we need x naught and y naught. If we have both these details, we can represent the equation of the straight line by this sorry, I wrote it in the opposite direction. This is the equation of the straight line that we can write. So basically we need these two information, right? The point that this line passes through as well as the slope of that line, right? And to find the slope, we use the derivative. We compute the derivative of y with respect to x, and to compute that we use the chain rule. And you can see that the derivatives of x and y with respect to thetas can be written like this because of this relationship. And remember, r is a constant, okay? And then by plugging in the values appropriately, you can get the relationship for dy by dx in terms of theta. And we have to find the tangent at the point this, right? So when theta takes this value, there will be a corresponding x and y value, right? So we consider those two x and y values as the x naught and y naught value. So this is basically the x and y values which corresponds to theta equals pi by 3, right? So that can be found by plugging in theta equals pi by t in our equation. So well, before that we can find the equation of the straight line or the tangent. We can find the slope of the tangent by plugging in theta equals pi by 3, right? So when you plug in theta equals pi by 3 in this equation, we can obtain the slope of the tangent, right? So we have the curve represented by the given parametric representation, and we have a point that corresponds to theta equals pi by 3, and we know that we can have a tangent like this. And now we know the slope of this tangent. So now we are left with finding the point that this passes through, right? So in order to find the point, we should substitute theta equals pi by 3 in the given these two equations, right? Then we have x equals this one and y equals this one by using these two equations. Now see, here we are not changing r because it's just a constant term, right? And then we can use all this information to come up with the equation of the tangent, right? So the equation of the tangent will be this one, root 3 x minus x naught, where you can have y naught and x naught in place of these two numbers, I mean variable terms, right? Well, this is not y naught, okay, this is just the value of x naught, right? And y naught you have to find it separately by substituting theta equals 1 over root 3. Then it will be 1 minus cos pi over root 3, and that will be equal to r by 2. So r by 2 goes here and this whole thing will go here, right? Then you will get the equation of the straight line at this point, right? Now if you actually draw this graph, it will have this nice shape of well, actually you will get this figure if you plot it correctly. And see, here you will have the radius, this number given in here. So the diameter will be 2 pi r. Okay, so this is called the cycloid. You don't have to remember all these diagrams, but you should be familiar with calculating these dy by dx terms. And diagram is you don't have to use any of the information from the diagram in order to calculate the derivatives and the tangents. So actually if you have a look at the diagram, you can see that theta equals pi by 3 parameter will be responsible for the x naught and y naught point in here, and you will be drawing this tangent, right? Okay, and then the next question is, at which points is the tangent horizontal and where is it vertical? So if you look at the diagram, you can see that in all these points you will get a horizontal tangent, and in all these points you will get a vertical tangent. So there will be infinite number of points where you have a horizontal tangent, as well as an infinite number of points where you have the vertical tangents. But as I said before, this diagram is not necessary to come up with those details, and you can see from the calculation itself you will get all those information extracted out. And to find the horizontal tangents, we have to equate dy by dx to 0. That means this is equal to 0. So by cross multiplying this term, you will get sine theta is equal to 0. And sine theta is equal to 0 means you will have all the odd multiples of pi. So for all these values, sine theta will be equal to 0. And remember, this is the value of theta that makes the dy by dx 0, but you have to find the corresponding x and y values. So you can compute it by substituting it in the given original equation, this one, right? So to calculate x, when you substitute this one, you will get 2n minus 1 pi minus sine theta, which is equal to 0. So you will have r times 2n, I will write it like this. So you will have 2n pi r minus pi r, okay, where n is an integer, that means 1, 2, 3 and 4, and also you can have the negative integers as well. And y value will be equal to r times 1 minus cos 2n 2 pi 2n minus 1 times pi. I am just substituting this theta value in the given equation. So this one, now you can see this is 2 times something which is a even number, and when you like an even multiple of this one, say for example if n is equal to 2, you will have 2 times 2 pi r minus pi r. Here you have 4 pi r minus pi r, you will get 3 pi r, right? Similar thing is there for all the integers. Let's say 3, then you will get 6 pi r minus pi r, which is 5 pi r. So what you can see is this will be an even number and even multiple of this term, and when you subtract this term from the even multiple, you will get an odd multiple of pi times r. So eventually you will have 2n minus 1 pi times r. This is the representation of an even number multiplied with pi times r. And when you say now, in order to calculate the corresponding y value, you can see that here you have r and here you have 1, and this number is always an odd multiple. So an odd multiple of pi will always, now if this is the axis of plotting the sine and cosine curves, odd multiple will always land on this axis, right? See, 1, 2 times pi, this is 3 times pi, and this is 4 times pi, 5 times pi, 6 times pi. Likewise, an odd multiple will always lie on this axis, right? So since theta is on this axis, cosine of that theta will always be a negative term, so negative 1, right? So you will have 2r in for y when theta is an odd multiple of pi. So basically what we have is a horizontal tangent at each of these points, 2n minus 1 pi times r and 2r, right? So these, for all these points you will get a horizontal tangent. You can even see that information in this diagram. See, for all the odd multiples of pi times r, you have a horizontal tangent, right? See, for all these things you will get a horizontal tangent, and you can obtain these terms by substituting negative values for the integer n written here, right? Okay, and finally, to calculate the the vertical tangents, and to compute horizontal tangents you will need the derivative to be equal to infinity. That means it's not a horizontal, I'm sorry, a vertical tangent. So the derivative should be equal to infinity, and that will come from having the denominator to be equal to 0. And in all these equating to 0 cases, we should make sure that now if we are equating the numerator, we should make sure that the denominator is not equal to 0, and if we are equating the denominator, we should make sure that the numerator is not equal to 0, right? And now in this case, since this is infinity, we should equate the denominator, right? So when you equate denominator to 0, you will have this one. So that means theta is equal to 2n pi, right? And now since this is the theta value, you should evaluate the corresponding x and y values, and you can see that when you substitute 2n pi in the given equation, this is an even multiple of pi for the sine trigonometric term, that gives 0. So you are left with 2n pi r, and here for the y-axis you have a even multiple of pi for the cosine term, which gives you positive 1. So these two will get cancelled out, and you will get 0 for the corresponding y-axis. And if you don't understand these computations that involve trigonometric terms, please let me know, okay? I can help you. Now even in the diagram also you can see that for all these cases you will have a infinite gradient, that means a vertical line as the tangent. See, in all these places you will have a 0 y coordinate and a even multiple of pi r, which is expressed in the equations that we derived. Now see, you don't really need to know these shapes to come up with the solutions for these questions, right? So the only thing that you have to understand is about computing the derivatives with the help of chain rule, since x and y are represented with the help of a third variable, right? So you should use these appropriate equations to come up with dy by dx, and also you should know what will happen to the dy by dx term when there is a horizontal tangent and when there is a vertical tangent.